In this video, we're going to cover section 9.1, which deals with hypothesis tests, just kind of laying the foundation and then getting into them a little bit more specific. There's quite a bit of material here. So we're going to talk about the null and alternative hypothesis test, what a p-value is, how to interpret it, how to determine if your results are statistically significant or not, and then what a type 1 and type 2 error are. So the null and alternative hypothesis are basically, the null is just a claim. So if somebody claims they make 80% of their free throws, it's a categorical variable. They make it or they don't. So we're using the parameter p. So p is 0.8. That's our claim. That's our null hypothesis. And our alternative would be like, nah, we don't believe this person. We don't think that they make 80% of their free throws. Maybe they make more, maybe they make less. Maybe we think they're just exaggerating, so we think it's less. So we call that the alternative. And what we're trying to do is see if we can gather enough evidence for the alternative. So, like a court of law, innocent until proven guilty. Do you have enough evidence to say that they're guilty, or you don't have enough evidence, and then you conclude that they're not guilty? This is called a one-sided test because we're just looking at less than. If it was greater than, it would be also a one-sided test. So what's a two-sided test? Two-sided test if you think the parameter is just going to be different. So I think the person is just not an 80% free throw shooter. Maybe they're greater than, maybe they're less than. So we say that they're not equal to. So this would be an example of a two-sided test or a two-tailed test. All right. So this check your understanding just asks you to do two things. Describe the parameter in words and symbols, and then state the null and alternative hypothesis. So pause the video now and work through these. Okay, in this first one, we are looking at percent of teens who are getting less than 8 hours of sleep. So the parameter would be P, the true proportion of teens who are getting less than 8 hours of sleep. And the null hypothesis would be P equals 0.85. And the alternative would be P is less than 0.8. Oh, I'm actually wrong. I was kind of wondering. She just wonders if this result holds true in her large high school. So she wonders if it's 85% or not 85%. So you could see that the alternative is not equal to. And I was about to say less than. So just be mindful of that. All right. Second part. The average household will take 10 minutes to complete. All right. So the parameter is mu. This is a quantitative variable. And it would be the true mean number of minutes it takes to complete this form. So the null hypothesis would be mu equals 10. The alternative, we think it's going to take longer, would be mu is greater than 10. Okay, hopefully that was helpful. Moving on. Okay, in significance tests, we use the sampling distribution to see, is the result of what happened in one sample unusual or not? So going back to the free throw example, here's a simulated sampling distribution. And this whole sampling distribution is based off the premise that this person makes 80% of their free throws. That's what this whole thing is based off of. So the likelihood that somebody makes 64% or less, if they're an 80% free throw shooter, only happened three times out of 400. That's less than 1%. For an 80% free throw shooter to make 64% or less of, in this case, 50 shots. Now we have like, wow, that's some strong evidence against this player's claim that he or she makes 80% of their free throws. So we start to think they might be lying and that the real value is less than 80%. Okay. So there's two possible explanations why they only made 64%. They just had a really bad day, and they actually do make 80%. It just happened by chance that they made 64% that day. Or the alternative hypothesis is true, that the real proportion is actually less than 80%. Okay. So that leads into this idea of a p-value. Again, going back to this idea of innocent until proven guilty, we assume they're innocent. We assume the null hypothesis is true. That's what the sampling distribution is based off of. So your p-value is, it's a probability. It's a conditional probability, like given the null is true or assuming the null is true, how likely is it that you got a statistic or something more extreme just by chance? So I want to go back for a minute. So to this one, assuming the person really makes 80% of their free throws, what's the likelihood I get a sample result of 64%, or in this case lower, or more extreme, or further away from the mean just by chance? Here it was 0.0075. Very unlikely to happen by chance. So then that leads us to evidence to start to believe that the alternative hypothesis is true. Okay. So here they're just kind of formalizing what I was saying. So if the player makes 80% of their free throws in the long run, there's about a 0.0075 probability that the player would make 32 or fewer shots by chance alone. So because that probability is so small, we have a lot of evidence against the null hypothesis in favor of the alternative. So it looks like the alternative is true. All right. Here's another scenario that you can look through. Again, you can watch the video. This is just dealing with the means because I see mu, so quantitative variable, and then interpreting the p-value in context. Okay. So p-value in context is insanely important that you understand what it is. We're going to be calculating a bunch of p-values. Like if you don't understand what they represent, then it's going to be hard to piece together what's actually happening. So that leads us to a decision we have to make about our hypothesis test and specifically our null hypothesis. Do we reject or fail to reject the null? So is the person guilty or not guilty? We reject the null if we have enough evidence for the alternative, and we fail to reject the null if we don't have enough evidence for the alternative. And we say convincing or not convincing evidence. One thing you should never do is this. You're never going to accept the null hypothesis. We're never going to say the person's innocent. We never say the null hypothesis is true or we accept it. We either have enough evidence to reject it or we don't have enough evidence and we fail to reject it. So this little mapping is nice. If your p-value is small, and we'll get into what that represents, then we reject the null and we have convincing evidence for the alternative. If the p-value is large, we fail to reject the null and we don't have convincing evidence for the alternative. A large p-value means what happened in the sample is likely due to chance. So how do we make that distinction? We use what's called a significance level. And this isn't going to be shocking. Our traditional significance level is 5%. And we denote it with alpha. So if our probability is less than 5%, then we say the p-value is small and we run through this. If the p-value is greater than 5%, we run through this scenario. And the significance level is typically 0.05. Sometimes it can be 0.01 or 0.1. So if we say the results are statistically significant at some significance level, alpha, that just means the p-value is below the alpha level. And we have convincing evidence for the alternative hypothesis. All right. Moving on. Type 1 and type 2 errors. So just in a court of law, like the jury could make the wrong decision. We convict an innocent person or we say not guilty when the person is in fact guilty. Those are the errors we can make when we do a significance test. If we reject the null when it's true, we call that a type 1 error. And if we fail to reject the null when the alternative is true, we call that a type 2 error. Both are bad depending on the situation. One might be worse than the other. So if we take a look at this, this is what percent of the potatoes are blemished on a shipment. Here, 8%, the alternative greater than 8%. And in essence, they're going to send the truck away. Say we're working at some potato chip factory. If more than 8% of the potatoes are bad, we don't want that shipment. We're going to send them away. So a type 1 error is you reject the null when, let me bring it back up here. You reject the null when the null is true. So what does that mean? That means we find convincing evidence that there's more than 8% of the potatoes that are blemished, when in fact it's 8%. What's the consequence? Well, if we find evidence that more than 8% are blemished, we just sent away a full shipment of potatoes that were actually okay because we thought they weren't. So that's going to waste time. That's going to waste money. Type 2 error, going back up here, is you fail to reject the null when the alternative is true. That means we don't find convincing evidence that more than 8% of the potatoes are blemished, when in fact, more than 8% of the potatoes are blemished. What's the consequence? Now we just accepted this shipment of potatoes that's really not high quality. So our products, our potato chips, are going to be all those nasty ones that people typically don't like. So that might affect how people view our product. Now, which is worse, type 1 or type 2? You could argue both ways. But you have to be able to identify the error in context and then the consequence of that error. All right. So better batteries on page 546. Let's see what happens when I do this. All right. Okay. So what they want you to do is describe a type 1 error in context and a type 2 error in context here. And do they also want you to get into which is more serious? Yeah. Okay. So at this point, pause the video and do a type 1 and type 2 error for this question. Okay. For type 1 error, that means the null hypothesis is true and we reject it, meaning we find convincing evidence that the batteries last more than 30 hours when in fact they only last 30 hours. That's type 1 error. Type 2 error, we don't find convincing evidence, or I'm sorry, we fail to reject the null, so we don't find convincing evidence for the alternative when indeed the alternative is true. So here that would mean that we don't have convincing evidence the batteries last longer than 30 hours, when in fact they do last longer than 30 hours. So the consequences for type 2, the batteries actually last longer, but we don't think they do. So the problem with that, it's going to be, let me bring it up. It'd probably be easier to read it than restate it. Okay. So type 1 error, they're spending more money to produce batteries when they don't need to. And type 2 error, that they're not going to produce batteries, but they should. So you can, the argument of which is worse is subjective, as long as you can justify why you believe one or the other to be worse. All right, type 1 error, probability. Okay, there's a lot going on here. Let me summarize it this way. The probability of making a type 1 error is the same as your significance level. So if you have an alpha level of 5%, there's a 5% chance that you make a type 1 error. So if you want to lower that, then use a smaller alpha level. Maybe I use alpha as 0.01. Now I only have a 1% chance of making a type 1 error. All right, so we talked about significance tests. It's just assessing evidence against a null hypothesis in favor for an alternative. You have 1 and 2-tailed tests, or 1 and 2-sided. 2-sided is when the alternative is not equal to. We talked about the p-value, the decision you make about your null hypothesis, you reject or fail to reject it, and then what's the type 1, type 2 error in context, and what are the consequences? Lots to digest.